Okay, so we want to graph this function g of x equals 7 minus natural log of x minus 4 using just the function natural log of x. Now you probably already have the graph, but I'm just going to draw this graph for my own sanity. So what does the graph of the natural log of x look like? Well, first of all, the important numbers are 0 and 1 over here, and the graph of natural log looks somewhat like this. It dips down but never quite touches the y-axis. So this is what f of x equals natural log of x looks like. Now we're going to transform this graph in the order that we usually do, H, S, R, V. So we're going to check each of these one by one and see which of these has happened. So we first start with H and see, is there a horizontal shift? So let me review real quick what it means to have a horizontal shift. You either need to have your x, a constant added to your x, or a constant subtracted from your x. If you have a constant added to your x, then you move left. And if you have a constant subtracted from your x, then you move right. So in this case, which of the two will it be? Let's see. Okay, I'm just going to rewrite this so I can highlight things. I have g of x equals 7 minus natural log of x minus 4. Okay, so in this case you'll see that you have x minus 4, which means it's an x minus c situation, so you're going to be moving right. So the horizontal shift that we're looking at is you're going to move right by 4 units. Okay, what's the next step? The next step is to check if there's an S. Now, S asks if there is a stretch or a shrink. A stretch or shrink is characterized by either having a constant multiplied to your x term or a constant multiplied to your entire function. Now, in this function, you'll see that you have neither. You don't have a constant multiplied to the x, neither a constant multiplied to your function. So we're going to say that we don't really have a stretch or shrink situation. Okay. Next, we move on to R. R checks if there's a reflection. Now, there can be two kinds of reflections. One is you can either have a negative sign on your x term, or you can have a negative sign to your function. Now, if the negative sign is on your x term, your x turns negative, which means you flip over the y-axis. Now, I know I say flip, but you can also say reflect over the y-axis. And if you have a negative sign to your f of x term, then your y turns negative, so which means in this case you reflect or flip over the x-axis. Let's see which of the two it is. So going back to our function, we see that we do indeed have a negative sign here, and the negative sign is in front of the function, so we're dealing with negative f of x, where you reflect over the x-axis. So the step 2, okay, I forgot to say this, oh, hang on. I forgot to say this was step 1. Step 2 is going to be you reflect the equation over the x-axis. Finally, we're done with H, S, and R. Finally, we want to check if there is any vertical shift at all. V is for vertical shift. Now, vertical shift is characterized by one of two things. Either your function itself has a number added to it, or your function itself has a number subtracted from it. Now, if a number is added to your function, in this case you move up, and if a number is subtracted from your function, in this case you move down. So let's go back and check quickly which of these two situations it is. Indeed, you see that you do have an extra 7 here. Now, since that 7 is positive, it's added. Now, I know you don't see it here, but this is like having a plus 7. So since you have a number added to your function, what it's going to be is that this is the situation we're looking at, f of x plus c, which means you move up. So the vertical shift that we're looking at, which is step 3, is that you move up by 7 units. So to summarize the 3 things that we're doing here in order to come up with this graph transformation is we first move right by 4 units, we reflect over the x-axis, and then we move up by 7 units. I'm going to show you what this looks like real quick. So let's see. So let me remind you that the graph of natural log of x looks like this, and the important points are 1 and 0. And just to be clear, this is the y-axis, and your graph of natural log of x never quite touches the y-axis but goes really, really close. So initially what happened is that the graph moved to the left. Was it left or was it right? Sorry, it moved to the right by 4 units. So if this point is at 1 here, what's going to happen when it moves to the right by 4 units? I'm just going to draw it in this graph, but maybe in a different color. So we move to the right by 4 units. That's 2, 3, 4, and 5. So it's going to move to 5. So this is, I'm going to draw a dotted graph. This is going to be your new graph. And well, let's also draw the line at, this is at 4. So your entire graph is just shifted to the right by 4 units. So this is what it looks like. Now there was no stretch or shrink, but there was a reflection. You reflect the graph over the x-axis, which means that what happens is all your y values turn negative. So if you're going to reflect this graph over the y-axis, well, okay, I'm out of colors, but let's pick red. So if you reflect this over the y-axis, or over the x-axis, I'm sorry, what's going to happen is that the whole thing just flips upside down. So this is what it would look like. This is the reflection, and let me also write that the blue is what happened when it moved right. Okay, and the final step is that it moves up by 7 units. Okay, so what do we look at? Let's look at this line 0. So what is going to happen is it's going to move up 7 units. So we're going to keep this in mind, 7, and what's going to happen is that it's going to move up 7. So I'm going to draw a quick dotted line here and keep this line here. So here the point that's directly up from here is 5, 7. So this is where your graph is going to be. Oh, never mind, it's supposed to be upside down, so it's the red graph that's moving up. So your graph is going to look somewhat like this. Okay, so this is the graph that you're looking for. Let me highlight that one. This one is your graph of the function g of x. Okay, and we're done.